right, recording has started. Um, all right, welcome to this webinar on solar energy. Before we get started, I want to take a moment to respectfully acknowledge that our work at EOS is done on the traditional and unceded lands and waters of the Mi'kmaq. Today's speaker is Woody Thompson. Woody is the manager at Fundy Solar and one of the most experienced solar installers in the Maritimes. And I'll let him give more of a background on his work. Before I turn things over to Woody, I'll just ask that everyone remains muted during his presentation. We'll keep questions to certain times and at the end of the presentation in order to stay on schedule. Please write your questions in the chat and I can relay them. If you're joining in on the phone, we will give you the chance to ask your questions too. Thank you very much, Woody, and I'll turn things over to you now.
Yeah, my name is Woody Thompson. Most of you, I know I've met most of you before, or all of you. I started in about 2000. I had the opportunity to do some work in West Africa in solar. So I took a course with the Great Lakes Renewable Energy Association out of Lansing, Michigan. And that was the only course in solar available at the time. There wasn't anything that I could find in Canada. And in 2003, I started Fundy Solar. I decided to move back to the Maritimes. And since then, it's been an interesting ride. Did a lot of solar water heating until about 2012. And then I decided to just focus on solar power systems. Moving to the next page here. I like the buttons on the screen, but it seems I've got to click the little thing on the, I like the buttons on the keyboard, but I've got to click the thing on the screen. So this is our sun, which is the source of all of the solar energy that we have here on Earth, and it is also the source of all of our fossil fuel energy. Sunlight comes into the atmosphere, and a lot of it is reflected by the atmosphere, by dust in the atmosphere, by clouds. Of course, it's also weather dependent. And a certain amount of solar energy does reach the Earth, and it warms the Earth. And then because the Earth is warm, it's re-radiated into space, a lot of it as infrared radiation, which keeps the Earth from overheating. But it seems that our modern industrial economy is taking care of that problem as well. Since the early days, solar power has been utilized by our civilization, and that includes the Greeks, the Romans, and solar water heating, which is a diversion from solar power, which is what I'm supposed to be talking about. But just as a point of interest, the Climax solar water heater was patented in Baltimore, Maryland in about 1892. So that's well over 100 years ago. And since then, solar thermal has taken off. In the early days, solar water heating was attractive because gas was expensive and dangerous. Later technology, this is also a solar thermal system built in a desert. And by the writing on the tower, you might conclude that this is somewhere in China. And what we have here are mirrors. And the mirrors are focusing the solar radiation onto an absorber at the top of the tower. That absorber heats water converts it into steam, and the steam drives the turbine and generates solar power. It generates power. The power is ultimately solar, but it generates electricity. Unlike the previous method of converting sunlight to solar power, today solar panels convert sunlight directly to electrical power at the subatomic level. And in a nutshell, a photon comes in, hits an electron, excites the electron. The electron has enough energy to cross the purple band gap, which is kind of like a one-way valve, like one of those turnstiles in a subway where you can only go through in one direction. And the electrons accumulate on one side of the cell, and because there is an accumulation of negatively charged electrons, you have a voltage. You put those electrons to work and you have utilized solar power. Solar cells are made out of silicon. And in this picture is a crystallized piece of silicon pulled out of a molten vat of silicon. And in the early days, solar cells were made by slicing this piece of silicon into thin wafers, and the wafers have impurities introduced, which change the crystalline structure of the silicon and create different electrical properties. I once felt I reached the limit of my understanding of how a solar cell works, so I asked a real physicist with a real PhD, and the answer he gave me about the more subtle points was more, I was more confused afterward than I was when I asked the question, so I'll leave it there. Solar cells were first utilized, and they were very expensive in the late 50s and early 60s on satellites. So here we have a picture of a satellite, and all the little squares are a whole bunch of little solar cells. And at that time, aerospace would be the only organization that would have the interest or the funds to be able to purchase solar cells. Each solar cell generates about 0.5 of a volt. Not very many appliances in our houses run off of 0.5 volts. So as a result, a whole bunch of cells are put into series, and they call that a module. And because they're placed in series, positive to negative, the voltage adds up into a higher voltage that is easily utilized for charging batteries or for powering an inverter that further converts the power coming from the solar panel to usable household power that can power our conventional appliances. So since the 60s, when solar was really, really expensive, there were people that wanted to live in cottages in the woods, far from everybody, out away from civilization. And they liked to have a few lights and a radio. So in around the late 80s into the 90s, solar modules got cheap enough that the ordinary person could afford to purchase one or two of them. So for a couple decades, solar power was used almost exclusively in the domestic market by people who wanted to live off-grid in a little cabin in the middle of nowhere. These systems utilized, of course, solar panels, and the solar panels were connected to a charge controller. And this is also how a lot of off-grid systems are done today as well. The charge controller's main function, is to prevent the batteries from being overcharged. And the charge controller is connected to the batteries. And there can be loads that operate directly off the batteries. Some lights are 12 volts, some refrigerators are 24 volts or 12 volts. And an inverter is also connected to the batteries, and the inverter converts the DC power from the batteries into conventional AC, alternating current, and that goes to a load center, which is the breaker box, which all of you have one in your house. And from there, it goes to your conventional appliances, your toasters, your washing machines, your refrigerators, etc. In around the late 90s, grid tie solar power systems became available, which do not use batteries at all. In a typical grid tie solar power system, you have a solar array connected to, again, an inverter, which takes the DC power off the solar array, converts it to AC, and it is connected to your load center, which sends the power to your appliances. If there is more power coming in than you are consuming, then the solar array, the solar power system, backfeeds the meter and sends the power onto the grid, and your meter will record the power that you are contributing to the grid, and your power company will give you energy credits that you can use at a later time. The placement of solar panels or a solar array is important. There's a few considerations. Due south is generally the best orientation for a solar array because the sun spends most of its time in the southern part of our sky. The sun is also much higher in the summer than it is in the wintertime. So the tilt angle, the slope of your solar array will have a bearing on how much energy you get and what time of the year you get that energy. This is a simple illustration of the relative energy yield that you will get from a solar array with various orientations. At our latitude, about 45 degrees north, a 45 degrees angle due south will get 100% of what you could potentially get from a solar array. If that solar array was placed vertically, you would get about 84% of what you would get if it was perfectly placed, and most of that energy would be coming in during the fall, winter, spring months. If the solar array is placed totally horizontally, you get 75%. If it's placed to the east, again, you get the picture. This was developed by Efficiency Nova Scotia, and it's a performance factor chart. About 2016, Nova Scotia came out with substantial rebates on residential solar installation. And as a result, suddenly the number of companies installing solar multiplied, and they ran into some substandard installations. So they had to create some parameters about the orientation and tilt of the solar array. And their requirement is that in order for a solar array to qualify, it has to be 70% or greater of the potential output that you could get. So you see here, due south at 45 degrees, it's 100%. And then as you get further east at 45 degrees or tilted further west at 45 degrees, the annual yield decreases. And on the vertical axis, you have your tilt angle from almost flat. And you notice that a solar panel placed flat will have the same annual yield across the northeast, south, and west, because with no tilt angle, there can be no orientation in respect to north. And then here we have a 90-degree solar module, and it is very sensitive to its orientation with respect to south. Different parts of Canada get different amounts of solar radiation. Even though Calgary, Regina, Winnipeg are further north in latitude than Nova Scotia and New Brunswick are, they get substantially more solar energy. And the reason for that is they have a lot fewer cloudy days. This is an inverter. Microinverters became available in around 2010 or 2012. Again, I'm not talking about in absolute terms, but I'm talking about they showed up on price lists that people like me would find from their suppliers. And this is a microinverter. And with microinverters, you have one inverter for every solar panel that is installed. And this is a roof where we are preparing to install solar panels. And here's all of our microinverters set out beforehand. You have to carefully measure and figure out where your solar panels are going to go so you can place the microinverters properly. And this is a bond that is a ground. The green wire is a ground that grounds all of the rails and all of the inverters. This is a job on Hanwell Street in Fredericton for the APEGNB, Association of Professional Engineers and Geoscientists of New Brunswick. And in about 2015, they had me put 60 solar panels and inverters on their building. So this is all of it was 3 runs of 20 solar panels. Because they were microinverters, the microinverters upload all of the data that they collect about the output power from the solar module. They upload it onto the web where it is recorded and it is accessible by the homeowner and by the installer. So here we see each individual solar module. This one gave 897 watt hours. This one gave 907 watt hours so far that day. And it gives you the historical yield, lifetime of the system, how much energy it yielded that month. As you can see, the lifetime of the system is about the same as the month, not a whole lot of difference there. The system was very newly installed when I took this screenshot. And the system, the microinverter system will also, and this is Enphase, which is one of many microinverter manufacturers. It also gives you a graphical display of the energy yield or the power output for any particular microinverter. So as you can see, early in the day, the sun comes up and the inverter starts to generate power. Around noon, it reaches a peak. And then in the afternoon, it drops off. And on July the 15th, we had a bit of cloud in the sky. So instead of having a perfect, almost a sine wave curve, we have a lot of interruptions in our power output curve because of the cloudy weather. One of the challenges of solar power being utilized on a large scale on the power grid is that solar power does not coincide with energy consumption. Typically, the peaks in energy consumption are in the morning, especially in the winter time. In the morning, everybody gets up, cooks breakfast, has shower, toaster, and then in the evening, everybody comes home, cooks supper, turns up the heat, has a bath, or their television lights are on. And the load on the power grid does not coincide with solar, which generally peaks sometime in the early afternoon. So managing the energy demand with solar as part of the equation is a challenge for utilities. Wind is another renewable energy resource, and wind corresponds fairly nicely with energy demand, and it also complements solar to a certain degree because the windiest months and the months where the wind resource is the strongest in the Maritimes tends to be the months where solar is at a minimum or not at all. And then there are other things like electric cars, which are becoming increasingly popular. And no, by the way, Tesla or Elon Musk did not invent the electric car. This is a shot from the early 1900s, probably 1905 or something, before the First World War even. And there were electric cars and there were internal combustion engines powering cars. And the internal combustion engine usually had to be cranked by hand. It was loud, it took gas, it burned oil, it took oil, and it was powerful. And the guys liked their internal combustion engine. They could fool with the spark plugs, fool with the carburetor. It was great. But the ladies, they just wanted to go get the milk and the bread down at the local grocer, and they didn't need to go far. So they liked the electric car. So they'd have a little electric car with the lead acid batteries in it, and they would just turn it on and trundle down to the grocery store at 20 miles an hour and go back, and no gas, no noise, no cranking, no oil, no spark plugs, none of that. No radiator fluid boiling over. So the electric car was a little bit of a player, even back in the early 1900s. And of course, currently, electric cars are again making a resurgence over 100 years later, and they are changing the energy picture for the grid as well. So somebody calls me up, hey, I'd like to get solar panels. If I can, the first thing I do is ask them for their civic address, and hopefully their house is more than 10 years old or so that it shows up on Google Earth, and I can look at their house and decide what I can do for them. So if somebody calls me up and say I live at 1 Garden Hill Avenue in whatever city this is, I look at their roof. Oh yeah, not too high, decent slope. On Google Earth, south is straight down. It's fairly well oriented to south. It's a little to the east, but it's pretty good. So I can measure the roof off of Google Earth and create an estimate for them. And I can also use the orientation and estimate the slope of the roof, which in this case is quite not very steep, probably 20 degrees. And I can estimate, I can plug that system that information into a program, and I can give them an estimate of the energy yield as well. If the person told me that they were at 1222 North Street and it happened to be this house, I would not be as enthusiastic. The orientation is okay, but it's very difficult to fit solar modules on a roof with these triangular shapes. Solar modules are square. And also, I see the roof is steep. It looks like it's made out of metal. It's difficult to work on because of the steepness of the roof. And the cost per watt for the red roof here would be much higher than it would be for the house down here. And then, of course, some people would have a house where it's shaded on the south side and the only feasible slope is facing north, in which case I have to tell them simply it's probably not worth pursuing. Review grid tie solar power system. The cost of solar has come down precipitously, even since I started into the business in around 2002 or 2003. And unlike your groceries and your fuel bills and the cost of getting your deck rebuilt, the cost of a sheet of plywood, for example, the cost of solar panels on my current price list is about as low as I have ever seen it. And I don't know why that is. I was listening to CBC a few days ago. They were talking about renewable energy on Atlantic something or other. And they said that China has installed more solar last year in 2023 than ever before. So they are producing solar panels, and when they decide they're going to produce something, they get very good at it. So it's probably solely a question of the volume of production is keeping prices low. But that's just a guess on my part. I don't actually know why solar panels are as surprisingly inexpensive as they are. This is the system in Fredericton completed. These are combiner boxes that transfer the cables from the inverter to conventional household wiring that goes in through the building. Solar modules may be installed on a ground mount. And this is a job in Cambridge, near Canning, Nova Scotia, and it's at Boats Apple Cider and Vinegar. I don't know if you've ever seen Boats on Sunday, apple cider, but these are those folks. And this is 16 module ground mount. This is another type of ground mount. Right at the end of the High Marsh Road. It's built out of pressure treated wood on screw piles. And this is actually my favorite type of ground mount right here. I think the wood is aesthetically pleasing. It's probably going to last 20, 25 years. It's not going to last forever like galvanized steel and aluminum will, but it will probably last the life of the equipment. Batteries. This is an off-grid system that I installed in about 2012. We have here a 4 kilowatt inverter and a battery bank. These batteries are made by Surrett Battery Company in Spring Hill, Nova Scotia. There's about 2,400 pounds worth of batteries here. I forget just how many batteries or what they weighed each. And these are lead acid batteries. Lead acid batteries have caps and they off-gas hydrogen and oxygen. hydrogen and oxygen are the atomic components of water, so they lose water over time. So you have to periodically add distilled water to the batteries. Another diagram of an off-grid solar power system, which we have previously reviewed. This is another off-grid power system. The batteries, it's much smaller. The batteries are located inside of this little box. This is a battery ventilation device. This is the inverter, charge controller to communicate with the inverter so that you can tell it when to turn off the inverter in case your batteries get too low. So you could set that at, if it was a 12 volt system, you could set it to like 11 volts or 10.5 volts. This conduit carries the conductors from the solar modules. And this is the load center with all the breakers in it. This system was installed in Nova Scotia. And then this is a grid tie power system with two inverters. Not too much to say about that. This is the load center. Battery comparison. The main batteries that are available on the retail market are lithium ion batteries and lead acid batteries. Lead acid batteries have been around much longer than lithium ion batteries. They're cheaper. They're heavier and larger. I think I've got a better, I should have a better version of that. Yes, here we go. This is my version. The other one was the official version, but this is my version of that. I can't see because of this thing here. Can I move it up? Okay. All right, lithium ion, we'll start with lead acid because they're older. Require a periodic full charge. So at least once a week, they have to be charged up to the point where they're actually boiling or gassing the electrolyte. So that all of the chemicals inside the lead acid battery are put back where they are supposed to be. If you leave a lead acid battery in a discharge state, it will lose efficiency over time. They're much less expensive as compared to lithium ion. They require distilled water be added periodically. They're much heavier than lithium ion batteries as well. Lithium ion batteries are more expensive, like 3 times as expensive. Lighter. Approximately the same physical dimensions for the amount of energy that they store. Each one has a charge management system, and that is a microprocessor that will disconnect the battery if it is being overcharged or undercharged, the voltage gets too low, or if the battery gets too hot, possibly if the battery gets too cold. And the purpose of that is lithium ion batteries are subject to what's called thermal runaway, where they start to discharge internally. And maybe you've heard about car accidents where firemen have a battery internally discharging and they can't stop the fire that it's creating because the battery is just converting all of its energy to heat, and you have tens of kilowatt hours of energy being released very rapidly that the battery's making so much heat and there's no way of stopping it. You just have to wait until it sort of runs out of electrochemical energy and stops making heat. They're more efficient, allegedly more efficient than lead acid. They can tolerate a deeper depth of discharge. So a lead acid battery, you have a lead acid battery that is claimed to contain or be able to hold 1,000 watt hours or a kilowatt hour, you should really only take half of the energy that that battery is capable of delivering, which would be 500 watt hours or half of a kilowatt hour. If you fully discharge a lead acid battery, the number of times that you can do that is severely limited, whereas a lithium ion battery is much more tolerant to deep levels of discharge, although deep discharges will also reduce the lifetime of a lithium ion battery. It's just that the effect isn't as great as it is with lead acid. And they also say longer, and I underlined and highlighted expected here lifetime, because that's what they're claiming, and they haven't really been proven in the field because they haven't really been out there that long. So in an off-grid system, which battery is going to last you the longest? A well cared for lead acid battery or a lithium ion battery? Well, that's a question that has not really been determined yet in real world conditions. They do this in the lab, but it's not a real world. So recently, all of the electricians, I guess, in New Brunswick were issued a letter by the chief electrical inspector for the province, Pierre Daigle. And I can send any of you this letter if you want to read it. We won't read it here because it's take long and it's boring. But Pierre Daigle's interpretation of his own letter, although it doesn't say this in black and white in the letter, is that only a red seal electrician is allowed to connect the pre-made MC connectors on a solar module together. So that pretty much rules out solar installers working on a roof, because you would have to have the electrician there with you all of the time to connect this two little MC connectors together. And these are pre-made. There's really nothing to do except push them together. Anyway, the upshot is that Pierre Daigle is trying to remove anybody who is not a red seal electrician from installing solar modules. Now, since the federal rebate program, solar has exploded in Canada and it has exploded in New Brunswick. And solar power is not part of New Brunswick Power's business plan. What is in their business plan? Well, that's something to discuss on another day. But so my theory, and I may be wrong, is that they want to slow down the installation of solar in New Brunswick. And one way to do it is to make it not possible for installers who are not red seal to install solar panels on a roof. Now, ground mount is possible because I can put the solar panels on the ground mount. I can have all of the MC connectors, which are the connectors coming off the solar array, all ready to be plugged in together, all set. And all the electrician has to do is come in and click, 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 and all of the solar modules are plugged in together, and then he can go do his usual routine operations of connecting the wires in the junction box and pulling the wires through the conduit, etc. And that concludes my presentation for February the 6th, 2023. Thank you all for coming out. I hope you enjoyed it. And I'll turn it back over to our MC, and maybe she'll open the floor for questions.
Thank you so much, Woody. That was amazing. So yeah, feel free if you're a guest to type your question in the chat box, or you can raise your hand and ask your question verbally. And yeah, bear with me. It's my first time hosting an EOS webinar. So I'm learning.
Woody,
Yes.
we have a question with climate change and increased cloud cover, perhaps. Do you expect that solar will be will be producing less if the cloud cover does increase over time?
If the cloud cover increases over time, which is a hypothetical statement, then yes, there will be less solar power available.
Do you think climate change is heading in that direction, or is that a little hard to theorize?
I cannot even start to theorize about our future energy patterns here in the Maritimes. Climate change is such a chaotic, and I mean, California, bushfires in the summer
Right.
and unbelievable rain in our winter, and that's just one example of many, many, so I mean, anybody's guess. I'm certainly not going to.
All right, next we have Lauren with a question, and then Roland after Lauren.
Great, thank you. I've been aware of like solar energy and that kind of thing for like 9 years now, and I still learn something new when I listen to Woody's presentations. I was just wondering, Woody, when you're looking at the graph of solar production, is it pretty, can you say that like a smooth curve means it's like a sunny day with no clouds, and if there's like jagged bits, that means there's clouds? Is that kind of, is that a fair statement?
Yeah, if I can, I'll go back to that
For sure.
image, but I don't know if I can get there. Oh, here we go. Okay. I assume you guys can see this, what I'm scrolling through here.
Yeah.
Let's see. It was here.
Yeah.
Yeah, so this would be sort of a sun and cloud kind of a day. As you can see, the peak is about as high as it is on the perfect days. And in fact, the peak could be a little bit higher because sometimes on a sun and cloud day, you'll have a cloud on each side of the sun, and the cloud will sort of reflect solar energy onto the earth, as well as the direct energy coming straight from the sun. But yeah, this is a kind of a sun and cloud sort of day. If it was just a cloudy day like today, then this might be a smooth curve. It would just only go up like that far, and then it would go back down.
Okay, great. Thank you.
You're welcome.
And Roland?
So Woody, I have questions regarding storage. We often see on social media, there's a product I can think of, EcoFlow, and they recommend this for your home use. My understanding, these lithium batteries that are about $3,000-4,000 wouldn't be able to suit a household because they can't, correct me if I'm wrong, but they cannot sustain the draw of devices that use too much electricity. Is that correct? And is that why the Tesla batteries are more expensive, because they can handle the draw of various appliances in the house that draw more energy?
A typical home uses about 20 kilowatt hours per day. The Tesla battery stores, I think, 7.5 kilowatt hours per day, and it costs about $15,000. So you can see your costs would add up very quickly. You'd be looking at 50,000 almost in the materials alone before it's installed, if you wanted to have something that could cover your energy use in your home typically. In a typical home, you have the major energy consumers are heat pumps or your heating system. Hot water tank takes about 3,000 watts. The kitchen range, electric kitchen range oven takes about 4,500 watts, at least 3,000 watts, depending on the model. And then each burner is about 1,500 watts, and you've got 4 of them up there. So you're looking at about 6,000 watts for all the burners on top of the stove. So a typical home really consumes a lot of energy or a lot of power if you just use everything and don't, you know, reduce your consumption. Backup batteries. Some of the least energy intensive loads in a home are lights, water, and refrigeration. And those are kind of the essentials. If the power goes out and you're stuck for a week in your home, what are the 3 main things that you would want to have? Well, lights, water, refrigeration, and communication. You could probably get away with not having your toaster and your coffee maker working, depending on the person. So you could have a system that gives you a certain amount of your circuits in your home backed up without having the major energy consumers backed up in your home. So you'd have to do without hot water and do without your kitchen range and things like that. But you would have lights, communication. Battery the rules around batteries have kind of gone the way of rules around solar installations in New Brunswick as well. The most recent electrical code created very high requirements for the installation of batteries because of the problems that have been demonstrated with lithium-ion batteries. But instead of having a section for the lithium-ion batteries alone, they just used the word batteries. So the new restrictions include lead-acid batteries as well. And some of these restrictions are that the batteries can't be installed in the dwelling space of your home. Can they be installed in a garage? Well, that's a question. Probably the electrical inspector would be the one to answer that. If he said that that's inside the dwelling space of your home, as an installer, you probably couldn't argue with that. And if he said it's not inside the dwelling space of your home and the batteries are allowed in a garage, well, that would also make sense. The electrical code is not as clearly defined as the 10 Commandments. So where I'm driving at with this is that it's also very hard to install batteries in a residential setting. Also, something I didn't mention about lithium-ion batteries is that most or all of them, and all of the ones that I have seen specification sheets on, cannot be charged when they are in sub-zero conditions. So if you're going to install them exterior to your home, then they have to be in a heated space. Otherwise, when the power comes on, or you have solar power available to charge your batteries, you will not be able to charge them until they are above 0 degrees Celsius. And that is a challenge in our maritime climate. So that probably answers your question and then gives you a whole bunch of other stuff too that you didn't see coming. But
This is a sub follow-up to that. There's some talk about technologies using a dual plug for your electric vehicle. So I presume in an electric vehicle, the batteries are protected more because obviously I drive electric vehicle in cold weather and it still works, though you lose some of the capacity. But do you have any update on these dual plugs that will allow to use your electric vehicle as a means of, as a backup of energy?
no, I haven't looked at that. I do remember Chevrolet with their version of the electric vehicle. I can't remember what it's called right now. Oh, I think it's called the Bolt. They did issue a bulletin that you were not to park your Bolt in your garage. For similar reasons with having to do with the batteries. But yeah, I haven't seen or really heard of the battery in the car being utilized as a backup for your home. Although that would make a lot of sense because most batteries in electric vehicles are 50 to 100 kilowatt hours of energy storage. So for a typical home, that would be a couple days. And if you were careful with your energy, then you could stretch that out probably to a week or two if you had to.
Yes, yeah.
Are there any other questions? I haven't seen any in the chat.
You did, didn't you do
I-
didn't you type something? She can't see it.
Oh, do you have a question, Andrew? Feel free to unmute or type it in the chat.
Yes, I've heard about being able to charge from several cards, or and I think the Ionic 5 is capable of doing that, and you can get an adapter from them, I understand. And I think there are other vehicles. I think the Nissan might have had that capability, but I don't know if they've actually pursued that line. But I think it's something that will probably be coming.
Yeah, I agree. It will probably be coming. It's right there. It just takes a little bit of changes in the technology, but the battery's there. There's enough technology built in the cars that it can invert that power from the battery, and it just makes sense. And then talking about peak shaving and things like that, the problems with peak load for power companies, they could also network with electric car owners to try to mitigate that issue as well. So I think it's coming. It's just not here yet.
Any more questions? We've still got a couple minutes.
Does he always use the pylons, or does he some?
Oh.
Because what happens if the ground is too rocky?
For ground installations, do you always use pylons, or if you have rocky areas, do you have another option?
The two things I have used so far for ground mounts are the screw piles, which are not good in rocky ground. Luckily here on the Windy Marsh, it's been a bunch of sand and clay been deposited over the millions of years, so there's not too many rocks here. But the other system that I've used is concrete blocks. They weigh about 3,500 pounds each, and they're not very expensive, a little more than $100 each. You need about 12 of them for a typical ground mount installation. And if you have a fairly flat area, then you can just set them on wherever you want your ground mount to be. And I attach the ground mount to that. And in my opinion, that is really the best solution, because concrete is going to go nowhere and it's going to last forever.
Which is, in a way, can be a disadvantage if you want to get rid of it at some point.
Yeah, then you'll have all of these giant blocks that you have to figure out.
Make a fort out of it or something.
Yeah. Sell them to the Department of Highways. They use them all the time.
Ah, right. Yeah.
Yeah.
Good.
Looks like there's a question from Peter.
Thanks, Jeannie. Woody, enjoyed your presentation. I was wondering about that. You made allusion to the metal roofs, and that I understand that metal roofs, you can't really work on them. So are metal roofs out for installation of this?
No,
You
no,
can.
not at all. Metal roofs are easy to work on. They're more challenging than asphalt in respect that if there's a bit of precipitation, you can't walk on the typical metal roof. But if you have a dry metal roof or a nice day to install, and it's facing in a good orientation to the south, that's ideal. For a couple reasons, one of which is that asphalt roofs, despite the manufacturer's claims, do not last very long, and by very long, I mean 30 years or 40 years. Typical asphalt roofs last about 20 years, and you will have to get it replaced, and then when that happens, you'll have to have the solar array removed. So metal is better, in my opinion.
Okay, and then the other would be the pitch of a metal roof. If it's too high a pitch, I guess it would be more difficult to install the panel.
Yes, if it's steeper, it's more difficult, but it's not impossible. It's just more difficult.
Thank you.
All right, if that's it for questions, I think we can wrap things up. Thank you so much, Woody. This was really informative. I learned so much.
You're welcome.
Yeah, this was awesome. Yeah, I'm gonna stop recording.